Okay, pre-cal students, in this video I want to very quickly yet thoroughly tie the 5 factoring videos together with 6 quick examples. So your heading today will be tying factoring together. Please write down today's date. The heading again is tying factoring together, and go ahead and write down today's date. Now, you see, anyone can take a polynomial and factor it when you already know what type of polynomial it is. It really becomes a true test of factoring skills when polynomials are all mixed together and you have to figure out what type of polynomial you are dealing with. So let's jump right into this and see how you students do. Let's look at 6 problems and see if you have the ability to first pull out what's common and then evaluate what type of polynomial you have left over so that you can then factor it properly. Take some really good notes. Here we go. Copy down this first problem in your notes. Negative 2ax cubed minus 6ax squared minus 4a to the x. Now, on a test or a quiz or a problem that we're working on in which you have to factor this trinomial, what would you do first? Well, you always pull out what's common first. And if your lead coefficient is negative, we usually, if not always, pull out a negative sign. Okay? Now, notice your coefficients are 2, 6, and 4. So the largest number that goes into all 3 coefficients would be 2. So I'm going to factor out a 2. Next, notice every term has an a. So I'm going to pull an a out. Notice this term has 3 x's, this term has 2 x's, and this term has 1 x. So the most x's that I can pull out from all of these terms would be just 1 x. Okay, so let's see what we're left over with. Step 1 is always pull out what's common. Well, it looks like I'd be left over with x squared here. Let's see if that's right. Negative 2ax times x squared would be negative 2ax cubed. Now here I would be left over with a positive 3x, I believe. Let's see if that's right. Negative 2ax times positive 3x would be negative 6ax squared. And now here I would be left over with a positive 2 because negative 2ax times 2 would be negative 4ax. And now students, please listen. Look at what you're left over with. Are you left over with a binomial or a trinomial? Well, a trinomial. Does it have a lead coefficient of 1 or does it not have a lead coefficient of 1? Well, it has a lead coefficient of 1. So if you'll look in your notes from days gone by in the past, you will see here are the steps that I gave you. In your notes, I told you that when you have a trinomial with a lead coefficient of 1, that you, of course, make sure the first exponent is twice as big as this exponent, and it is. 2 is twice as big as 1, and you make sure the third term is a constant term, and the third term is a constant term, and then you list out all of the factors of the constant term. So if I list out all of the factors of the constant term, I would have 1 times 2, 1 times 2. Okay, now notice I have a positive 2, so I would want a positive times a positive and a negative times a negative, and then choose the correct set of factors and factor. Well, I look at my middle term, it's a positive 3. Only one of these groups adds up to a positive 3, and it's this group here. So my factorization would be negative 2ax, and then go ahead and put your 2 parentheses, and notice your middle term here is an x term, so I'm going to put x plus 1, and then I'm going to put x plus 2. There we go. So what you should have noticed there is you always pull out what's common, and then you look and see what you're left over with. And I was left over with a trinomial with a lead coefficient of 1, so I used these steps here. All right, let's try another one. Again, we're going to move pretty fast today, so if you need to pause the video and take some good notes, that's fine. All right, go ahead and copy this problem in your notes, please. Now, we're going to factor this polynomial. The first thing you do is you pull out what's common. Well, I have a coefficient of 2 and a coefficient of negative 128. So I'm going to pull out or factor out a 2. And if I do that correctly, here I would have an x to the 9th, because 2 times x to the 9th is 2x to the 9th. And then here I would have 64, because 2 times negative 64 is negative 128. So I pulled out what's common. Now, I didn't pull any x's out because this term here had 9 x's, but this term over here had no x's at all. So I could not pull out an x out of this term over here. So I did pull out what's common, and now students, look at what you're left over with. Are you left over with a binomial, or are you left over with a trinomial? Now, if you're left over with a trinomial, we had how many types of trinomials? We had one that had a lead coefficient of 1, and then trinomials that did not have a lead coefficient of 1. But this is not a trinomial. This is a binomial. And we studied 3 types of binomials. Remember? Perfect squares, and then 2 different types of perfect cubes. Okay? So we've got to look at this and decide, do I know the square root of both of these terms? Well, I do know the square root of 64, but I do not know the square root of x to the 9th. So am I dealing with 2 perfect squares? No. This right here, x to the 9th, is not a perfect square because you cannot take the square root of it. So I'm not dealing with a perfect square. Well, maybe I'm dealing with perfect cubes. Let's see. Can I take the cubed root of x to the 9th? Well, I would like to say yes, you can, because the cubed root of x to the 9th would be x to the 3rd. How do I know that? Because x to the 3rd times x to the 3rd times x to the 3rd equals x to the 9th. Remember, when you're multiplying like bases, you add the exponents. So I do know the cubed root of x to the 9th. Do I know the cubed root of 64? Sure I do. 4, because 4 times 4 times 4 is 64. So both of these terms, here and here, are perfect cubes. So I'm factoring the difference of perfect cubes. And so if you'll check your notes, here are the steps that I gave you for when you're factoring perfect cubes. Okay, and here it is. Well, actually, we kind of did it more from just writing the actual parts down, but let me go like this, let me pull this down a little bit. We make sure that we have a binomial in which both terms are perfect cubes, and we did that, and then we simply factor. So do you remember how to factor? Look in your notes if you need to. Whenever you're dealing with perfect cubes, you put a small parentheses, and then you put a bigger parentheses. And then in your head, you take the cubed root of x to the 9th, and the cubed root of x to the 9th is x to the 3rd power. Then in your head, you take the cubed root of this term here, 64, which is 4. And then whatever your sign is right here, you bring that down, you put it right here. Now, next, we're going to have a trinomial over here. You take this term, and in your head, you multiply this term times itself. So x to the 3rd times x to the 3rd would be x to the 6th. Now, to find this middle term right here, you take this term and you multiply them together in your head. Well, x to the 3rd power times 4 would be 4x cubed. And then you take this term here, and in your head you multiply it times itself. So 4 times 4 would be 16. And then remember, this term here is always positive, this term here is always positive, and this middle term here will always be the opposite of whatever this sign is right here. So if I have a negative sign here, then this sign here would be positive. And that's it. We did it. We're totally finished. Okay? So there, we factored a binomial that was the difference of 2 cubes. All right, let's continue on. Okay, take some really good notes. Now, step one is always pull out what's common. Well, let's start with your coefficients. We have a 6, a 9, and a 42. Well, the largest number that goes into all three of those numbers would be 3. So I'm going to factor out a 3. Next, I have 5 x's in this term, 3 x's in this term, and 1 x in this term. So the most that I can pull out of all of these terms is just 1 x. So I'm going to put an x here. And now let's see what we're left over with. Here I would put 2x to the fourth, because 3x times 2x to the fourth would be 6x to the fifth. Here I'm going to put 3x squared, because 3x times 3x squared would be 9x cubed. And then here I'm going to put a negative 14, because 3x times negative 14 would give me a negative 42x. There, I pulled out what's common. Now, after you pull out what's common, you ask yourself, am I left over with a binomial or am I left over with a trinomial? Okay, now if you're left over with a binomial, we looked at perfect squares and perfect cubes. If you're left over with a trinomial, we looked at ones that have 1 for a lead coefficient and ones that do not have 1 for a lead coefficient. Well, what am I left over with, students? Am I not left over with a trinomial? Sure I am. Okay, so I'm left over with a trinomial, and is this trinomial right here? Is it one that has a lead coefficient of 1, or do I not have a lead coefficient of 1? Well, I do not have a lead coefficient of 1, I have a lead coefficient of 2. So we're going to have to use the steps that you were taught earlier in a previous video about factoring a trinomial that does not have a lead coefficient of 1. So here we go. Let's go ahead and see if we can't. Let me grab this and pull something out of the way here. Alright, there we go. And here we go. Alright, pull out what's common. We did that. Make sure the lead coefficient exponent is twice as big as this exponent, and it is. Make sure you have a constant term right here, and we do. Multiply, step 3. I'm going to put a check mark here, a check mark here. Step 3, multiply the lead coefficient and the constant term together. List out all of the factors of this product. List each set twice. Okay, no problem. Here we go. Here's your lead coefficient 2. Here's your constant term here. Multiply those two together. 2 times negative 14 is a negative 28. Now let's list out very quickly all the factors of 28. Now notice it's a negative 28, so I would want a positive times a negative and a negative times a positive, and a positive times a negative, negative times a positive, so on and so forth. Okay, there we go. So I did step 3. Step 4 says choose the correct set and then rewrite the trinomial as a 4-term polynomial. Well, let's choose the correct set. I do that by looking at my middle coefficient. It's a positive 3, and so I'm looking for a set that adds up to a positive 3. Here it is, right here. There it is. Okay, so those are the numbers I'm going to use. So I'm going to go ahead and bring down my 3x, and I'm going to go ahead and rewrite this trinomial with 4 terms, which is what it says to do in step 4. So I bring down my 2x to the fourth, I bring down my negative 14, and then right here in the middle, do not write positive 3x squared. Notice you have an x squared term. Instead, you're going to write negative 4x squared plus 7x squared. Now I got the negative 4 and the 7 from this group right here, and I used an x squared because my middle term here is an x squared. So there we go. I did step 4. Step 5, pull out what is common in the first 2 terms and pull out what is common in the last 2 terms. So here's what I'm going to do. I'm going to go, and then step 6 is factor. I'm going to go ahead and get this out of the way so we have more space. Okay, now I'm going to pull out what's common out of these first 2 terms right here. Okay, so here we go. I'm not even going to pay any attention to these two terms, just forget them for a second. All right, well, I know if I have a 2 and a 4, I can pull a 2 out. And I know if I have 4 x's here and 2 x's here, I can pull 2 x's out. So I'm going to factor out 2x squared. And I'm going to use a smaller parentheses. And let's see. Here I would put x squared because 2x squared times x squared is 2x to the fourth. Here I'm going to put a negative 2 because 2x squared times negative 2 would be negative 4x squared. Now let's take a look at our last two terms right here, and let's pull out what's common. Now I definitely can factor out a 7 because 7 goes into 7 and 14. I cannot pull any x's out of these two terms because the negative 14 does not have an x with it. But once again, I can factor out a 7. So I'm going to pull out a positive 7. And when I do that, I'm left with x squared minus 2. There we go. Because 7 times x squared is 7x squared. 7 times negative 2 is negative 14. Now, bring down your 3x, and then remember you write your matching parentheses once. And notice this parentheses here does match this parentheses here, and it should. So I'm going to write x squared minus 2, and then cross those off. You're done with those. And then in the other parentheses, you're going to write down the terms that you factored out. We factored out a 2x squared, and we factored out a positive 7. So here I'm going to write 2x squared positive 7. Students, you really should be able to do this very quickly now, okay? You need to be very, very familiar with factoring trinomials that do not have a lead coefficient of 1. Okay, let's continue on to another problem. Okay, here we go. The first thing you always want to do is pull out what's common. Now you should notice both terms do not have an x, so you cannot factor out an x. You should also notice you have 16 here and a coefficient of 1, even though you can't see it, so there's really no whole number you can factor out. However, remember, we really don't want our first term to be negative, so I'm going to factor out a negative, and I'm going to put 16 minus x to the fourth. Okay? Now, let's see if that's right. If I were to take this negative sign and multiply it back through, I would get a negative times a positive is a negative 16, and a negative times a negative is a positive x to the fourth. So I just factored out a negative sign. If that's confusing to you, then look at it like this. We factored out a negative 1. Same thing, okay? Now, what are you left over with? Are you left over with a binomial, or are you left over with a trinomial? Well, if you'll look, you're left over with a binomial, so we don't have to worry about trinomials. And what kind of binomial is it? Do we have perfect squares? Do we have perfect cubes? Or maybe neither one. Maybe it can't be factored any further. Well, let's see. Do I know the square root of 16? Well, yes, I do. The square root of 16 is 4. 4 times 4 is 16. Do I know the square root of x to the fourth? Well, yes, I do, because x squared times x squared equals x to the fourth. So yes, I do. Okay, so I have two perfect squares, and here's how we learn to factor those. I taught you to do this. I taught you to put two little parentheses. Notice you bring your negative sign down. You can't just drop that. And you put two little parentheses. And then in your head, you take the square root of this term here, and the square root of 16 is 4. You put it here, and you put it here. And then in your head, you take the square root of x to the fourth, which is x squared. So you put an x squared here, and you put an x squared here. Okay? And then you make one positive, and you make one negative. Now, there was one other thing I forgot to check up here, and I apologize for forgetting to mention this. It's my fault. And please don't miss this. This is very important, students. Whenever you're factoring the difference of perfect squares, your first term must be positive, and your second term must be negative. That's very, very important. Now, some of you, and by the way, we're not finished yet, and you're like, we're not done. Well, no. Remember, this is a pre-cal class, so we're going to do higher level thinking problems. When you look at this first parentheses, it cannot be factored any further. I mean, yes, you have a binomial. 4 is a perfect square. X squared is a perfect square, but remember, when you're factoring dealing with perfect squares, the first term has to be positive and this term has to be negative, and it's not. But look at your second parenthesis, students. Look, do I know the square root of 4? Yes. Do I know the square root of x squared? Yes. They're both perfect squares. Is the first term positive? Yes. Is the second term negative? Yes. So you can factor this parentheses down into 2 more parentheses like this. And so the square root of 4 would be 2. The square root of x squared would be x. Make one positive, make one negative, bring down this parentheses. That cannot be factored, and then bring down your negative sign, and now you're finally finished. There we go. Now again, if I've gone too fast, just pause the video and back it up and watch this again. But I want to show you something else some of you might have done. At the very beginning up here, some of you might have realized there was nothing to factor out, and instead of factoring out a -1, you might have just written your positive term first and your negative term second. If you did that, that is totally fine. I have no problem with that whatsoever. That is great to do. And I'm not sure why this isn't working. There we go. That is great to do. And if you did that real quick, here's what you'll go really fast. Here's what you would get. The square root of x to the 4th is x squared. X squared. The square root of 16 is 4. Make one positive, make one negative, and then you cannot factor this parentheses any further. And you say, well, Mr. Earhart, you have a perfect square here and a perfect square here. Yes, you do, but when you're dealing with perfect squares, the first one's got to be positive, which it is. The second term has to be negative, and it's not. So you cannot factor this first parentheses any further. However, look at the second parentheses. Is x squared a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. Is the first term positive? Yes. Is the second term negative? Yes. So we can factor this parenthesis some more. In your head, take the square root of x squared. That's x. So we put an x here and an x here. In your head, take the square root of 4. That would be 2. So put a 2 here and a 2 here. Make one positive, make one negative, and now we are finally done. So either one of those two factorizations would be acceptable. I would have no problem with either one. Okay? All right, let's continue on. A couple more problems. Okay, always pull out what's common first, and we've done that. There's nothing that you can pull out. Actually, we always want our first term to be positive, don't we? So let's go ahead and factor out a negative sign. There we go. So now we're left with x cubed minus 3x squared plus 4x minus 12. Okay, so there were really no numbers I could factor out, and there were no x's I could factor out. However, you don't want your first term to be negative, so you pull out a negative sign, and then all of your signs in here will change. Okay? Now, having said that, now we look at what we're left over with. Are we left over with a binomial? No. Are we left over with a trinomial? No. We are left over with a 4-term polynomial expression, so you should know what to do. You simply pull out what's common in the first 2 terms. Well, let's see. I have a 1 here and a 3, so I can't pull out any whole numbers. However, I have 3 x's here and 2 x's here, so I can pull out 2 x's out of my first 2 terms, and I'm left with x minus 3, because x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Now over here we can pull out a 4. Okay, so let's go ahead and pull out a positive 4, and we should be left with x minus 3, because 4 times x is 4x, and 4 times negative 3 is negative 12. Notice there was not an x in both of these terms, so you could not pull out an x. Now bring down your negative sign, write your matching parentheses once, x minus 3, and then in your other parentheses, you're going to write x squared plus 4. And you're finished. Now, a lot of students would say, hold it, you're not done, Mr. Earhart, you could factor this parentheses further. Well, hold on a second. Do I know the square root of x squared? Yes, it's a perfect square. Do I know the square root of 4? Yes, it's a perfect square. However, whenever you're factoring perfect squares, the first term has to be positive and the second term has to be negative, and your second term is not negative. So you cannot factor this parentheses any further, so you are completely finished. So there, we factored a 4-term polynomial expression. And now we have one more to go and we'll be finished for the video, okay? All right, here we go. First of all, always pull out what's common. Well, there's a 1 here and an 8 here. So there's really no whole number I can factor out. I have x's in this term, but there are no x's in this term, so I cannot factor out an x. There is a y in this term here, but there's no y in this term, so I cannot factor out any y's. The one thing I do want to do, though, is I want to factor out a negative sign because my first term is negative. So I'm going to pull out a negative sign, and that leaves me with x cubed plus 8y to the 6th. Okay? Now, are we left over with a trinomial? No. Are we left over with a 4-term polynomial? No. We're left over with a binomial. Anytime you're left over with a binomial, you see if you have perfect squares or perfect cubes. Well, we definitely don't have perfect squares because you could never take the square root of x cubed. However, we do know the cubed root of x cubed. The cubed root of x cubed would be x, because x times x times x is x cubed. And I do know the cubed root of 8y to the 6th because think about it. The cubed root of 8y to the 6th. Well, you know the cube root of 8 is 2 because 2 times 2 times 2 is 8. You know the cube root of y to the 6th is y squared because y squared times y squared times y squared is y to the 6th. So we have two perfect cubes. This term is a perfect cube. We know the cubed root of it. This term is a perfect cube. We know the cubed root of it. So do you remember what to do? You bring down your negative sign, you put a little parentheses, and then you put a larger parentheses, okay? And here we go. In your head, you take the cubed root of this term here. Well, the cubed root of x cubed is x. And then in your head, you take the cubed root of this term here. Well, the cubed root of 8y to the 6th would be 2y squared. And then whatever this sign is here, you bring it down and you put it right here. Easy enough. Now I've got to fill in 3 terms here. Okay, 3 terms. Well, the first term here, remember how we get the first term? We take this term here and we multiply it times itself. So x times x would be x squared. Now, for this second term here, do you remember what to do? For the second term, we take this term here and this term here and we multiply them together in our head. So x times 2y squared would be 2x y squared. And then do you remember how to find this last term? You simply take this term right here and you multiply it times itself. So 2y squared times 2y squared would give you 4y to the 4th, okay? And then remember, this term here is always positive, this term here is always positive, and then whatever the sign of this term right here is, the opposite sign goes right here. So if this is positive here, then you'll put a negative sign right here. And that's it. We're finished. There's nothing else you can do to this. So I hope you're seeing now how to factor these polynomials when they're all grouped together, okay? We have learned how to factor trinomials, 2 different types, lead coefficient of 1 and not lead coefficient of 1. We have learned how to factor two types of binomials. We're dealing with squares and cubes. And then of course we've also learned how to factor a 4-term polynomial. Okay, so that's what you really need to be familiar with. Okay, it's very important you can do this well and do it quickly. Okay, if you have any questions, don't hesitate to call or email.